This is Evan with EB3D Printing. In this video, I'm going to give a quick overview and guide for Jyers Firmware for the Ender 3 V2. I will link to this GitHub page in the description below. First, you may be asking yourself, what is Jyers Firmware? Well, Jyers Firmware is a custom fork of the stock Marlin firmware that comes on the standard Ender 3 V2. It takes the stock firmware and enhances it by unlocking options that were either not available or makes existing options better. Next, you may be asking yourself, well, why would that make me want to upgrade? The stock firmware works just fine, and you would be correct. Creality's default firmware works well out of the box, so to say, but it can be better. So in the following sections, I'll go over a few ways that the Jyers firmware improves upon Creality's default firmware. The first feature that I'm going to cover that Jyers firmware unlocks is EEPROM saving. Creality's stock firmware does not support EEPROM saving, or at least it did not support EEPROM saving. Newer builds may have implemented this feature. What Creality's firmware does instead, though, is take the settings and stores them, or tries to store them, to an SD card. If you do not have an SD card installed, guess what? Your settings aren't going to get stored. With EEPROM settings enabled, the Ender 3 V2 is able to save your settings, such as bed leveling mesh, Z offset, PID AUTOTUNE, and other data to the mainboard storage. And that data stays on the mainboard even after the power is cycled off and cycled back on. Your printer is then able to pull this data from the mainboard and use it for printing purposes. The second feature that Jyers firmware includes is the recognition of the M600 command by the Ender 3 V2. This may not be a main attractive feature for some, but if you've ever wanted to do a multicolor print, using the Marlin built-in M600 or Advanced Pause feature is a lot more user-friendly than trying to use some post-processing script or custom G-code. By default, the Ender 3 V2 does not accept N600 commands from the slicer. If it encounters an M600 command in the G-code, it ignores it and continues printing. The Advanced Pause feature allows for parameters such as unload length, unload feed rate, fast load, reload length, reload feed rate, and purge length, meaning that the printer will handle the bulk of the filament change operation. You just have to make sure that the filament is removed and replaced into the extruder. To do this in PRUSASLICER, you need to make sure under printer settings, custom G-code, that the color change G-code is M600 Advanced Pause. Then when you slice your file, click the plus icon next to the layer height bar to select the layer at which you want to do the color change. In CURA, you have to go to Extensions, Post-Processing, Modify G-code, then enter the layer at which you want the filament to change. You can also specify the park location for the nozzle during the filament change. When the filament change occurs, the nozzle will park at the designated location. The screen will prompt you to insert filament to continue. Do not press continue yet. This is when you remove and replace the filament. However, if you take too long, the nozzle will go into cooldown. So once you have the filament changed, you may be prompted with the nozzle reheat screen. Press continue to reheat the nozzle. Once the nozzle is reheated, you will then be prompted saying that it is up to temperature. Select continue. The extruder will then reload the filament and then purge out the previous color. Once the printer is done going through the purge cycle, it will pause to let the filament cool. This is when you use something like a pair of tweezers or a pair of pliers to pull the filament away from the nozzle. Once the printer has done the pause cycle, this is when it will continue printing. Here is a demonstration chip cube with a filament change from white to black inserted at layer 50. The third benefit that Jyers firmware offers is the option to PID AUTOTUNE from the display. Instead of having to connect via interface such as Pronterface or Octoprint, you can just do it right from the display. To reach the PID tuning menu, you'll want to go to Control, Temperature, PID, then select either the nozzle or bed. You'll want to set the temperature to a temperature that you most frequently print at, say 200 degrees Celsius for PLA, and then just wait for the nozzle or bed to reach the desired temperature. To give a quick overview, PID, or proportional integral derivative, is essentially a control algorithm that the printer uses to set and control temperature. This algorithm determines how fast the printer heats up or how consistent it holds that temperature. The more accurate this algorithm is, the more consistent your bed and nozzle temperatures will be. Once the bed or nozzle reaches that temperature, it'll go through cycles. These cycles will fluctuate the temperature up and down, with each cycle using different values for the PID tuning. The number of cycles will depend on the number you've set them at. Typically 5 is enough. After the printer is done running the PID auto-tune for the nozzle, you will be prompted with a PID tuning done screen. Click the scroll wheel to confirm. You will be presented with the new PID values for the nozzle. Then hit back, scroll down to the bed, and repeat the process for the bed. Once the bed reaches the temperature, it will begin the same process as the hot end by fluctuating the temperature up and down, although the fluctuations will not be as drastic. Just like with the nozzle, once the bed is done running the PID auto-tune, you will be presented with the PID tuning done screen. Click confirm, and you'll see the new values. It is at this point you'll want to save these values to EEPROM, so hit back, back, then back one more time, and scroll down to Store Settings. Your new PID values will now be stored to EEPROM. One time that you'll want to perform a PID auto-tune is when you notice your bed or nozzle temperatures fluctuating quite frequently and having swings of 10 or more degrees Celsius between the highs and lows. This indicates that your PID tuning might be slightly off. The fourth benefit that I will cover that Jyers Firmware offers is the option for manual mesh bed leveling. As I explain a bit about manual mesh bed leveling, you will see me going through the process in the background. This feature alone could single-handedly be the main attraction for upgrading your firmware to Jyers. Manual mesh bed leveling could save many frustrating hours of trying to get that perfect first layer. What the manual mesh allows for is Ender 3 V2 owners who have not yet or do not want to install an auto bed leveling system like the Bltouch to essentially get the same benefits of an auto bed leveling system. What the manual mesh allows for is you move the print head to set points around the bed manually, and at each one of those points you set the Z offset for the print head. For Jyers Firmware, you have the option of a 3x3, which would be 9 set points, or a 5x5, which would be 25 set points. The more set points you have, the more accurate your mesh would be. To set the Z offset at these set points, it's almost the same as the 4-corner turn the knob method, where you take a piece of paper like a post-it note and drag it under the nozzle until you feel that piece of paper vibrating. You want it snug, but not snug enough to where it buckles the paper when you try to move it. Once you have the right Z offset, you move to the next point using the next point option of the display menu. After you're done setting the Z offsets for each of these set points, you can then store that mesh to the EEPROM, which your printer will then pull from during the printing process. But in order for your printer to use this mesh, you will need to add the line M420 S1 to your start G code in your favorite slicer. To get to the manual mesh menu, you'll want to scroll down to leveling and click the scroll wheel. If you do not have a mesh level already active, you will want to select create new mesh. This starts the leveling process. Leveling active will be checked off once you have created a new mesh. Next, we will go into the create new mesh menu. The Z position is the height of the nozzle currently away from the home or 0 position. I will touch on microstep up and microstep down in a little bit. Go to mesh value takes you to the previous set value for the point your nozzle is currently at. If there is no mesh, that value will be NaN. To raise or lower the nozzle, click on Z position, scroll right to raise, and scroll left to lower the nozzle. After you've gotten the nozzle close to the position relative to the piece of paper, you can use microstep up or microstep down to raise or lower the nozzle by 1/100th of a millimeter to precisely fine-tune the nozzle height. After you have the correct nozzle height, click on next point to go to the next point and repeat the process until you are done the mesh. Once you have a mesh established, you can then view the mesh through the Mesh Viewer menu. You also have the option to show mesh values and have the mesh be asymmetric. Mesh Viewer allows you to then fine-tune the mesh by showing you the highs and low points of the bed, which you can then adjust through the manual tuning menu option. Once in the manual tuning menu option, you can then select mesh point X and or mesh point Y and go to a specific point of the mesh. Once you are at that point, you can adjust the Z offset for that particular point using the microstep up or microstep down option. This is extremely useful if you notice parts of your first layer are off. You can then adjust the points around that part of the first layer to fine tune it. The last feature that I'm going to mention, as there may be others that I've missed, but this one really stands out, is display customization. This allows the user to customize the display to their liking. You can change things like brightness of the display from 255 the whole way down to 1. You can change the progress as, so it's displayed as hours and minutes. There's a whole bunch of UI color customization you can do. You can change the cursor color, menu line, split line color, the highlight box, progress percent, progress time, the status bar text, status area text, the coordinate text. This is where the nozzle is during the printing process. And as you can see, this allows you to make for a very uniquely customizable display. You can even turn the display off. So if you're printing at night and you want the display off, you can turn it off. You just click the scroll wheel to turn it back on. As we go back to the main menu here, you can see that, you can change just about every aspect of the display. Now that we've gone over some of the benefits that Jyers Firmware offers, it's now time to pick a version that's right for you. I will link to this page in the description below. But looking at this list, it can be a bit overwhelming for new users to understand what they are looking at. I'm going to simplify that process by explaining and demonstrating the differences between each version. Looking at this list, the very first question you should ask yourself is, do I have an Ender 3 V2 or not? If the answer is no, then this firmware more than likely isn't for you. The second question you should ask yourself is, what motherboard version does my Ender 3 V2 have? There are two motherboard versions that the Ender 3 V2 can come with from Creality. The first is the 4.2.2 version of the motherboard, and the second is the updated 4.2.7 version of the motherboard, which fixes some of the overheating stepper driver issues that the 4.2.2 had. So now that we need to figure out what motherboard you have, I'll give you a demonstration of how to figure that out. The first thing you'll want to do is remove the display. Once the display is off, next take the 2.5mm hex key and loosen the 3 bolts and T-nuts that hold the display bracket on, and then remove the bracket. Once the bracket is off, you take the 2mm hex key and remove the 2 top motherboard housing bolts. You will have to just slide the bed forward to remove the rear bolt. Once the rear bolt is out, unplug the machine and proceed to turn it on its side, being careful not to drop it. Again, take the 2mm hex key and remove the 3 bottom bolts of the motherboard housing. Mine will look a bit different than yours, but the bolts are in the same locations and they're the same size bolts. After all 3 bolts are removed, slowly remove the motherboard housing cover. There will be a 40x10mm fan that is attached to the motherboard. This connector will be hot glued on. Just gently lay the cover on its side. You'll want to then look for the Creality logo in the middle of the motherboard. The version number will be below either 4.2.2 or 4.2.7. Next, we will just reverse the process and reassemble the motherboard housing, starting with the 3 bottom bolts. Once the 3 bottom bolts are in, we'll flip the machine back over and install the 2 top bolts. Now that we've figured out what version motherboard you have, the next question you have to ask yourself is, do you have a Bltouch or not? The answer to this is pretty straightforward. You will either have a Bltouch installed or you will not. If you have a Bltouch installed, you'll want to look for versions of the firmware that have Bltouch in their name. It'll either be the standard 3x3 mesh or the 5x5 mesh, or the unified bed leveling mesh, which is a 10x10 or a 15x15. If you do not have a Bltouch installed, you will want to look for versions of the firmware that have the Ender 3 V2 default firmware, or manual mesh, or the UBL NOPROBE 3x3 or 5x5. Now that we've determined if you have a Bltouch or not, I'll go over the different mesh styles for each firmware. I'm going to start with the NOPROBE versions of the firmware. If you have a Bltouch, you can skip over this section. I'll leave a timestamp in the description below to take you to the Bltouch section. So first up, if you're completely happy with the standard 4-corner turn the knob style leveling, you'll want to pick this default version of the firmware. This gives you all of the same benefits of Jyers Firmware, such as display customization, PID auto-tuning, M600 filament change, and EEPROM saving, but without mesh leveling. If, however, you want to incorporate manual mesh leveling into your printing, you have 2 options. First option is the standard bilinear mesh, which is represented by these manual mesh versions of the firmware right here. The second option is unified bed leveling mesh, which is represented by these UBL NOPROBE versions down here. These meshes are built the exact same way as I demonstrated in the manual mesh leveling section of this video. The difference between them is the algorithms used to calculate the mesh in the firmware. To keep this video from dragging on, I plan on doing a dedicated video going over the differences between unified bed leveling mesh and bilinear mesh. But for now, just know that they are built the exact same way. They're just calculated a little bit differently. For the Bltouch variations, you have 2 options for building the mesh. They are the same as manual probing, that is bilinear mesh or unified bed leveling mesh. Bilinear mesh is represented by the Bltouch 3x3 or 5x5 variations up top. Unified bed leveling mesh is represented by the UBL Bltouch variations right here in the middle. These, unlike manual mesh, are not built the same way. The bilinear mesh variations are built how you are probably familiar with the Bltouch building the mesh. That is, probing points in a straight line across the bed, then moving back and probing another set of points across the bed in the opposite direction. The unified bed leveling mesh is built quite a bit differently. It is built from the middle of the bed out. It probes points in a back and forth motion from the front to the back and left to right on the bed. Another difference, once the meshes are built, is the mesh view is displayed differently as well. Unified bed leveling mesh probes a significantly more points than bilinear mesh, so the mesh viewer displays a lot more points, as you can see by the screenshots presented. As I mentioned in the NOPROBE section, I plan on doing a dedicated video for unified bed leveling. Right now though, if you would like to go with unified bed leveling, my one suggestion is that your printer is at least very consistent and that you have upgraded to yellow springs or even better silicone spacers. The last 2 choices you have in regards to picking a firmware include the number of probe points and speed. The number of probe points affects both manual mesh and Bltouch versions of the firmware and are represented by the 3x3 or 9 probe points, or the 5x5 or 25 probe points. So here's a quick demonstration showing the difference between the 3x3 mesh and the 5x5 mesh. These are both Bltouch variations, and they are also the high-speed versions, which I'm going to discuss in a little bit. But as you can see, the bottom does 3 probe points across the bed, and then it goes back 3 probe points. The 5x5 does 5 probe points across the bed, and then it also goes back 5 probe points. 3x3 and 5x5 are both options for the manual mesh probing for the bilinear mesh and UBL mesh. 3x3 and 5x5 are only options for Bltouch's bilinear mesh. The UBL mesh for Bltouch uses a 10x10, which is 100 probe points, or a 15x15, which is 225 probe points. Typically, the more probe points, the more accurate the mesh will be for both manual and Bltouch. The last point I want to make is when choosing a firmware, you have 2 options for speed. This only affects the Bltouch versions of the firmware, but you have a choice between building your mesh at a regular speed or building your mesh a little bit faster, which is represented by these high speed or HS versions of the Bltouch firmware. Here's a quick demonstration showing the difference between the high speed mesh and the normal speed mesh. The top, as you can see, with the normal speed mesh, the probe fully retracts between each probe point and each probing of that probe point. On the bottom, however, with the high speed mesh, the probe just goes down and touches the bed twice before it moves on to the next probe point and repeats the process. So now that we've gone over the different variations of the Jyers firmware and you have one picked out that you want to install, the first thing we have to do though is install the display firmware. So from the main Jyers Marlin GitHub page, we go to code, download zip. We save that. Once that is done downloading, we click show in folder. Now this is a zip file, so we need to extract it. I use 7-zip. You can also use WinZip to extract this. You can also use the built-in Windows file extractor. I just prefer 7-zip. It's quick and easy. So you extract to Marlin, hit that extract. Once it's extracted, we dive into the folder. We go into display firmware, firmware sets. Now there's different sets here. The original basically uses the original icons. Gotcha and custom have different icon styles that they use. I just go with the original. So what we do is we copy this, take this over to the SD card, we paste it. Now after we paste it, we have to rename it. So we take off the original, so that way it is just named DWin set. And then once we rename it, we basically go up to Drive Tools and hit Eject. Now that the SD card is ejected, we're going to head over to the printer and install it. Once we are over at the printer, anytime you're working on the electronics of the printer, you want to make sure the power is off and the power cable is unplugged. After the power cable is unplugged, we'll want to go ahead and remove the display from the mount and then disconnect the display cable from the back of the display. After you have the display cable disconnected, you'll want to go ahead and take the 2mm hex key and remove the 4 bolts holding the back of the display case to the front. Yeah, what would be an EB3D video without me dropping the wrench? And apparently also a bolt. After the 4 bolts are out, just pop the back of the display case off. You'll then want to take the micro SD card and insert it into the SD card slot on the back of the display. After the card is inserted, plug the cable back into the back of the display. There's no need to reassemble it for this part. Once the cable is into the back of the display, we'll want to go ahead and plug the printer back in and power it on. Once the power is on, the screen will be the normal blue color, but then you'll see it switch to this bright blue color. Once it switches from the bright blue color to the orange, that's when the display firmware is flashed. You'll want to go ahead and power off the printer at this time, and then we'll go ahead and do the reassembly process after we unplug the display. We will start by removing the SD card from the SD card slot, and then putting the back of the display case back on, making sure it's popped securely in place. And then reinserting the 4 bolts that hold the back of the display to the front. We'll tighten those down. Once those are tightened down, we'll want to go ahead and put the cable back into the back of the display and putting the display back on the mount, and then just turning the power back on, making sure that the display firmware is correctly flashed. And as you can see, it's correctly flashed. So now that we've gone through and installed the display firmware, it's now time to install the motherboard firmware. You have the version picked out that's right for you. Me personally, I use this Bltouch 5x5 high speed for the 4.2.7 board. So all we do is click on the version we want to download, save the file. Once the file is saved, show in folder, right click on the file, copy, take that over the SD card, paste. Once it's pasted, same thing, eject. Now that the SD card is ejected, we're going to go over and install it onto the motherboard. Now that we are over at the printer with the micro SD card that has the motherboard firmware installed, we want to make sure the brass contacts on the micro SD card are facing up. Insert the card into the motherboard slot. We power on the printer, and now we wait. A Creality logo will pop up after some time, and a progress bar will begin to fill up. Once this progress bar is filled up, that means the new firmware is installed. We can check this by going to Control, scroll down to Info, and make sure the build number matches the build number of the version of the firmware we've installed. The final prep before printing mainly pertains to Bltouch versions of Jyers Firmware. There are a few more steps we have to take to make sure everything is ordered before we start printing. First up is the probe X and Y offset. This is the offset of the probe tip to the nozzle tip. The printer needs this info in order to have the proper home location to begin bed leveling for the building the mesh. I'm going to demonstrate what happens when you have an incorrect probe offset. As you can see, something doesn't look right. The probe is nowhere near close to the center of the bed as it homes. And then, as it moves to the first probing location, the probe is actually off of the edge of the bed. After the probe tries to probe this first location, it'll just stow the probe and then say that leveling is complete when it didn't level anything. So what we're going to do is we're going to cancel this and then go set the correct XY probe offset location. To do this, we'll want to go Control, Advanced, Probe X and Y offset. The X offset for the stock location is -44 and the Y offset is -8. After this, one thing I forgot to do is store the settings. So make sure you don't make the same mistake I did and store the settings. After the settings are stored, we'll go back and try the bed level again. Confirm leveling. As you can see this time, the probe is in the center of the bed, so that means we have at least the correct X and Y offset. As it moves to the first location, it is still on the bed as it probes the first point, and that means we do have the correct X and Y offset. Next up is the Z offset. The Z offset is the height difference between the probe tip and the nozzle tip in reference to the bed. In order to set this, we'll go to Prepare Z offset. We will first want to check the Live Adjust checkbox. This will move the print head to the home location. Once the print head is in the home location, we'll then want to adjust the Z offset down by clicking the scroll wheel on the Z offset label. We'll then turn the knob left to lower the nozzle closer to the bed. This step is much like manual leveling, where you take a piece of paper and continue to adjust the height until the paper is snug, but not snug enough that the paper buckles when you try to move it. You'll want to listen for or feel for the buzzing of the paper between the nozzle or bed. This lets you know that the nozzle is at the correct height. Once you have the nozzle at the correct height, you'll then want to store the settings by scrolling down and clicking on Save. One last piece of info I want to give on prep work is preheating. Anytime you want to set the Z offset or level of bed or manual level of bed, you'll want to preheat it. This is due to heat expansion causing dimensional changes between the nozzle tip and the bed. So pick whatever material you're printing with to preheat, and then once it gets the temperature, set your things. The last section I'm going to cover are slicer setting changes you need to make in order to have Jyers Firmware work properly. So first up, starting in PRUSASLICER, what you'll want to do is you'll want to go over here, this top left corner. You'll go to Printer Settings, down to Custom G Code. And the section we're going to focus on right here is the Start G Code. So somewhere in your G code, you should have a G28 command, which homes all the access. After that G28 command, you'll want to add the lines either G29, which generates a new mesh before every print, or M420 S1, which loads a saved mesh that you have currently stored in EEPROM. Now, I want to reiterate this. For the Bltouch bilinear versions of Jyers Firmware, you only want one of these two commands in your Start G code, either G29 to generate a mesh or M420 S1 to load a saved mesh. You do not want both in your Start G code. I have both of these in here for just demonstration purposes, and if I were to generate a G code right now, the printer would ignore the M420 line because of this semicolon before it. Semicolons designate comments in G code, which the printer basically ignores and skips over. For a bilinear mesh, I would highly recommend using the G29 command because the print bed on the Ender 3 V2 is so small that it takes a few minutes before every print to just run a simple mesh and generate the mesh. With M420-S1, yeah, you're loading a saved mesh you already have, but if you ran a print, took that bed off, and then put it back on, with Creality beds being so inconsistent in their flatness, you may not put the bed back in the same exact spot. So like the high point or low point of the bed may be slightly off, which would cause your mesh to be slightly off. So that's why I highly recommend the G29 command over the M420 S1 for Bltouch probing. For manual mesh leveling, you only have the M420 S1 option. Now, moving on to unified bed leveling, I'm just going to touch on this a little bit. Like I said, I need a dedicated video for this because this is just way too many options. But to keep it simple, I highly recommend for unified bed leveling to generate the mesh before running any print and then save that mesh to the EEPROM through the display. To load that mesh, you'll need to add the line G29 L0. The L designates loading the mesh. The 0 designates loading the first saved mesh you have stored in EEPROM, which would be the one you stored from display. After that, you'll need the line G29J. The J basically probes the bed before the print, like doing the G29 command, but instead the J adjusts your current saved mesh based off of the probe points that it generates during the J command. Now the number after the J represents the number of probe points. This number is squared. So if you have no number, it probes 3 probe points. If you have 2, it probes 4. If you have 3, it probes 9, 4, 16, so on and so forth. So that is the main difference between the bilinear mesh and the unified bed leveling mesh, is you can actually adjust current saved meshes with the unified bed leveling mesh, where the G29 you have, with bilinear mesh, you have no such option. Next up, we have CURA. This should go a lot quicker since I already explained everything in PRUSASLICER. All right, so for CURA, you're going to want to go over here to this top right corner. They drop down the printers, go to Manage Printers. Next up, you're going to want to go to Machine Settings. And then let me adjust this really quick so you can see it. Come on, there we go. Okay, so again, we're going to focus on Start G code. After the G28 command, home all access, you're going to want to add the line either G29 to generate a mesh or M420 S1 to load a mesh. Again, you only want one of these two, not both. Or if you're running the unified bed leveling mesh versions, again, you'll want to add the G29 L0 followed by the G29 J2. The last slicer of the free slicers that I'm going to go over is ideaMaker. So in ideaMaker, you want to go over here to this play icon, press the play icon, and then the gear icon. That brings up the advanced settings menu. You want to go over here to G code. And again, we're going to focus on the Start G code tab. After G28, you'll want to add the lines either G29 or M420 S1. If you're using unified bed leveling mesh, again, you'll want to add the line G29 L0 followed by G29 J2. And that is it for slicer settings changes you need to make for Jyers Firmware. Well, that wraps up this sort of overview / guide to Jyers Firmware. If you would like to support Jake or Jyers and his work, I have a link to his Patreon in the description below. If you would like to support this channel, you can do so through the Ko-fi link in the description. If you have any questions or comments, feel free to leave them in the comments section. I'll try my best to answer any and all questions I can. If I can answer, there's a link to the Jyers Wiki below as well. If you like this video and want to see more content from me, well, you know what to do. Until next time, I'd like to thank you all for checking this out, and I'll see you in the next one.